Hello, this is Mr. Stansbury. I'm going to take you through the notes on laws of exponents. At the end of this, you should be able to say, I can use the 7 laws of exponents to simplify exponential expressions. So let's take a look at those 7 laws. All right, so if we've got x cubed times x squared, we can write that. Really, x cubed is x times x times x, and then x squared is x times x, right? Which is going to give us x to the 5th. So the simplified version of that, instead of writing it all out like that, we can say, oh look, x to the 3rd times x to the 2nd. We add the exponents, and then we're good to go. Okay, so we could write that as x to the not even x. Let's do. I guess we could do that. X to the a times x to the b equals x to the a plus b. So we're just going to add those exponents. Okay. X cubed over x squared would be x times x times x over x times x. Those reduce down to 1, those reduce down to 1, and we're left with just x to the 1st, right? So to look at this, we actually take the exponent on the top and subtract the exponents on the bottom. So it'd be 3 minus 2. So x to the a over x to the b is equal to x to the a minus b. Okay, x cubed quantity squared is really x cubed times another x cubed, right? Which is x to the 6th. So what we want to do this is we have 2 sets of 3. So 2 sets of 3 is 2 times 3. So that means that we are going to write x to the a all to the b power is going to equal x to the a times b. Okay, so we're coming up with our exponent laws from what we can see over here. Okay, xy to the 3rd, you can think of that as x to the 1st, y to the 1st, but really it's xy times xy times xy, right? So that's 1, 2, 3 x's, so that's x cubed, and 1, 2, 3 y's, y cubed. So that means if we have xy to the, say, a power, each one of these is going to get one of these. Let's see, there should be, you know what, I'm going to change this a little bit to make this hopefully a little bit more sense. So let's say if this is, let's make this x squared times, and then y the 1st, all to the 3rd power. So that's going to be xx there, xx there, and xx there. So that would be 2, 4, 6 x to the 6th, and then y to the 3rd. So just so you know, we're going to 3 times 2 and 3 times 1. So how would we write that here? Let's say x to the, let's do this, x to the a, y to the b. Let's just, I don't know, we'll change this a little bit, see if this helps make more sense. And then it's all to the c power is going to be x a times c, a times c power, and it's going to be y to the b times c power. Okay? Kind of the same thing as what we had up there, but just so you know. X over y all to the 3rd power. Let's do the same thing here. Let's say this is x squared, and we'll leave that as y to the 1st. So x squared over y to the 1st, all to the 3rd power. So that's going to be xx over y times xx over y times xx over y, right? There's 3 sets of those. So that's going to end up equaling x to the 6th over y to the 3rd. So if we have x to the a over y to the b all to the c power, it's going to be x times a to the c over y times b to the c, b times c, sorry, b, a times c, b times c. Okay, x to the negative 3rd. The negative power basically means you're going to move it to the, let's call this as x to the negative 3rd all over 1. We're going to take this whole power here and move it to the other side of the denominator, and that's going to turn into a positive. So this will be 1. We're just going to leave a 1 on top to hold the place, and then x to the negative third is going to go to the bottom as x to the positive third on the bottom. All right, so x to the negative a, not 9, but a, is going to equal 1 over x to the positive a. Okay, and then last one, x to the 0. Anything to the 0 power is just equal to 1. Okay, so x to the 0, really that's kind of like the whole formula right there, is equal to 1. All right. A nice way to maybe show that just really briefly is if we have, say, x, let's not even do x, let's do 3 squared, 3 to the first, 3 to the 0, 3 to the negative first. So 3 squared is 9. 3 to the first is 3. So to get, let's even do 3 cubed. That's 27. So to get from 27 down to 9, we divide by 3, the base number. To get from 9 down to 3, we divide by 3. To get down to that's the base number. 9 divided by 3 is 3. And so to get to the next one, 3 divided by 3 is going to be 1. And then 1 divided by 3 is going to be 1 over 3. Right? There's our divide by 3. And look, there's your negative exponent, right? Because that's 3 to the first. If it's 3 to the first on the bottom, this 3 to the negative first turns into 3 to the positive first on the bottom. Okay? All right, let's take a look at a few examples. All right, but first let's do a little video comedy break here.
Where are you going? Where are you going?
Okay, let's use what we just learned to simplify these. Okay, so simplify 3 to the 4th times 3 to the 8th. That is going to be 3 to the 4 plus 8, or 3 to the 12th on that one. Okay, simplify this here. The bases are the same, so we, if you have one over the top of the other, it's subtraction, right? 6 to the 5 minus 2 is 6 to the 3rd. All right. Oh, oops, I'm going down when I should be going sideways here. Sorry, x to the 3rd times x. Now, if there's no exponent there, it's the same. It should always be a 1. So just put a 1 in there. So that's x to the 3 plus 1 is x to the 4th. Right? And this one here, again, subtraction. T to the 5 minus 4 is t to the 1st, or simply just t. Okay, and on this one here, a power raised to a power, we're going to multiply these. So that's 5 to the 2 times 4, which is 5 to the 8th. And we can just leave all these in exponential form, that's fine. And then r to the 3 to the r to the 3rd to the t power is r to the 3 times t. So we would just write that as r to the 3t and call that good. All right? All right, let's look at some more examples. Right as a power of 3. Excuse me for all these. 27 is, 3 times 3 times 3. So that is 3 to the 3rd power. Negative 27 is negative 3 times negative 3 times negative 3. So that's negative 3 to the 3rd power. 81. 3 times 3 is 9 times 3 is 27 times another 3 is 81. So this is going to be 1 over 3 to the 4th. Now we could also write this as 3 to the, if it's positive 4 on the bottom, we can move it to the top and turn it into 3 to the negative 4th. So depending on how the question is asked, if they say write it without fractions, you'd have to write it this way. If they say write it without negative exponents, we'd have to write it this way. But either one of those would work just fine. 1. 3 to the 0 power is going to give us 1, because if you remember, anything to the 0 power gives you 1. Okay, 81, we just figured out over here, 81 is 3 to the 4th. And then 9 is 3 squared, and that's all to the n power. So that's 3 to the 4th times 3 to the 2n. Okay, so when we have a power, when we have a base raised to a power times the same base raised to a power, we're going to add those exponents. So it's going to be 3 to the 4 plus 2n power. All right? Yeah, we'll just leave it at that. There's other ways to write that, but that's probably the best way there. So 9, we know 9 is 3 squared, so that's 3 squared to the r. All over 27 is 3 to the 3rd. So let's see, this 3 squared to the r power is 3. We got to multiply 2 times r, so 3 to the 2r over 3 cubed. And then we're going to subtract that. We're going to move this up to the top here and change that exponent to negative. So that's 3 to the 2r minus 3 would be our final answer on that one. Okay? All right, we're going to call this good for the first half of the laws of exponents, and I'm going to make a second video to finish this one off. All right, so if you have any questions on this, please feel free to ask in class. Thanks.